On space station, we have elements provided by all the different partners, and these elements were manufactured in many different locations, and also these elements were delivered to orbit in different time frame. In fact, some of them are still on the ground. And in order to be able to combine them and to be able to attach them, we had to develop methodology to assure that they would fit without actually mating them together on the ground. Mating them together on the ground is not really a possibility because some of them were not completed before some of them were launched and some of them are already on orbit. The one significant point also to cover is the following, that even if all of those pieces of hardware were manufactured at the same time, and even if you were able to deliver them to the same launch site, which there was different launch sites where they were launched from, but to take and then mate them on the ground under 1G conditions is a very highly risky situation because you could significantly damage the hardware due to handling issues and handling accidents. Give you an example, before we flew Node 1, we mated 2 PMAs to Node 1. And initially the thought was that we were going to hold it with the crane to mate the PMAs to Node 1. But then the decision was that it was too risky, so you had to have some special mating devices that we have built. We put the PMA on it, which was basically a transfer table, very high precision transfer table, and we were able to do a mate and safely perform it, but those flew together. Now, if you were trying to take and then mate two pieces, with using cranes and using some GSE, you have a very high risk of damaging the hardware. And of course, the other reality is that these pieces of hardware were built at different times, so they did not exist on the ground at the same time, so you could not even have performed that. But even if you did, mating them together, very, very risky, very high risk, because of the 1G environment and controlling the position and controlling the loading that you're going to induce into those interfaces by that mating act is very risky. Now, there were some individuals who proposed taking the entire station and mating it on the ground and all at the same time, not in just interface to interface, but every element, and that would have been an impossible task, really to perform without damaging hardware. The methodology that we developed was a twofold methodology. One methodology was to take and have mating tools, which were basically mating tools that were attached to either side of the interface before that element was completed, to assure that it properly mates to the mating device. One example is the common berthing mechanism, the CBM, which had an active half and a passive half, and so we took and the mating tool, which we refer to as the 1410 mating tool, we mated it to the active half, and on the other element that was provided by another partner, we mated it to the passive half to assure that it fits. We also used the mating tool to check out the functionality of all the electronics and all the actuation devices to achieve proper mating. We did very similar activity on the trusses, the U.S. trusses. We had mating tools, to assure that either side of the interface would be properly mated and physically fit, all the attached bolts and all the attachment devices. Again, an example of that is that the P6 truss, which is on orbit, will be mated to the P5 truss, which was just delivered to orbit, and then you want to be able to be sure that you have a proper mating when you mate the two together. The other activity that we did, in addition to the mating tools, was digital pre-assembly, or the DPA methodology. On the DPA methodology, we have built CAD images of all the hardware, not only at the interface where we mate, but also at the surrounding areas to assure that we have proper clearances for docking or proper clearances for berthing. There are many miscellaneous hardware pieces in the area, and we had to be sure that there is proper clearance for all of the envelopes that we needed for mating the two heads together on orbit. The digital pre-assembly method was initiated back in one of the airplane programs, and it basically consists of building some CAD models and then validating the CAD models with actual measured dimensions. The methodology for the dimensions that was used was twofold. Some laser measurements, of the interfaces and dimensions where they located at. Also some digital imagery, some video imagery and methodology, and some of this proprietary methodology, but which gave basically the data that could be fed back into the CAD models to verify that they're all accurate. So far, this methodology worked very well. Half of the station is up there, and all of the mating devices, have so far performed very well. I don't know if you recall, but way back some time ago on one of the satellite mating issues, when we recovered a satellite, there was some hardware in the way which prevented us to be able to do that. And so this methodology is very, very highly recommended, for future programs. Now the actual tools, the actual measurements probably is a better technology available today than what we have used on station, but it's imperative, that be performed. We sent the DPA teams to all of the partners' sites, and they performed the DPA measurements, the laser measurements and the video measurements, at the sites, on every piece of hardware. The teams went to Moscow in the dead of winter, to measure, FGB and service module before they flew, and then also the teams went to Japan, to measure the Japanese elements, and to Italy. And so this has been a continuous activity that our team has been performing. Now for Constellation, the one interesting thought on implementation is that one contractor builds, say, CEV, one contractor builds a launch vehicle, and, to work all these issues, the TMV group is, very actively, I'm sure, involved in this, but who actually does the work is one problem to solve, but that's a minor problem. If you pre-position some hardware on a lunar surface or on a Mars surface, and then 2 years later some other hardware is completed that you bring in to mate to it, then you of course have to have the proper fit, and you don't have a way to recover from it if you didn't do the proper preparation to begin with.